Okay, so good morning and welcome to lecture 3. So in lecture 3, we're going to focus on partial fractions. So we're going to learn how to resolve partial fractions and also use apply integration on partial fractions. Okay, so actually you have done this in calculus 1, the resolving of partial fractions, but we're going to revise it. Okay, so if we have a function 1 over x minus 2 plus 3 over x plus 1, then how can we make this into a single fraction? Then our common denominator is x minus 2 and x plus 1. So these are our common denominators. So when x minus 2 goes into there, we just have 1 multiplied by, okay, so we'll just put 1 multiplied by x plus 1, then plus 3 multiplied by x minus 2. When we multiply that and expand, we have x plus 1 plus 3x minus 6 over x minus 2 and x plus 1. We group the like terms. X plus 3x gives us 4x, and 1 minus 6 gives us minus 5 over x minus 2 and x plus 1. Actually, even the denominator, we can expand it further to give us 4x minus 5 over x squared plus x minus 2x minus 2. This will give us 4x minus 5 over x squared minus x minus 2. Okay, so this is how we make two functions into a single function. So actually, the process of moving from, okay, you can say this is the equation. Okay. So this process of moving from the single fraction into the two individual functions is known as the resolving of partial fractions, the resolution of partial fractions. Okay. Sorry about that. So this is the process that we're going to be dealing with. Suppose you're just given this function. How can you take it back to those functions, the individual functions? Okay, so this is a very common practice in integration as well. Okay, so we have some rules or properties that you need to take note when resolving partial fractions. Okay, so when you are resolving partial fractions, the first thing that you have to take note is that the denominator must be factorized. Okay. Then the numerator must be at least 1 degree less than the denominator. So if the degree of the numerator is higher than the denominator, then you have to divide the numerator by the denominator. So here what we are saying is that if the numerator has maybe an x, here down there I should have maybe x squared. Okay. You should never have this x squared over x. If you have this, then you have to divide the numerator by the denominator. Okay. Okay, so these are some of the rules that you have to take note when resolving partial fractions. So there are types of partial fractions. So the first one is partial fractions with linear factors. Then we have partial fractions with repeated linear factors, And finally, we have partial fractions with quadratic factors. Okay, so we start with the first case, the partial fractions with linear factors. Okay, so when we have linear factors, let's have an example. Example, just